So surface tension measurement is a very recent topic. So for example, your Newton's law, your theory of elasticity is out maybe 200, 300 years old, whereas surface tension measurement is, even now, things are developing. Okay, so that is a problem with metrology. Things are changing so fast. Nobody is able to even write a book. By the time the book will be obsolete. Many things are changing. So many standards are coming out. So now the craze is three-dimensional roughness parameters. That is just coming up. Instrumentation is just being developed, and it is still in progress. So let us see the history of surface tension measurement. So one of the first methods used was based on a fingernail. So somebody will just scratch the surface with a fingernail. Then light section microscope. So the narrow slit of light or a narrow flat beam or the light is made to fall on the surface and it is reflected back and viewed. So that is one method, 1936. So it is less than 100 years old. So whereas many of the other topics are very old compared to this subject. So then profilometer optical. So using optical methods and smoke mirrors and all, some instruments were developed long back in the 40s. Then electronics only started making this surface measurement a practical proposition. So electronic profilometers started only with valves and then transistors, made it very small. And now, of course, digital computers have revolutionized surface finish measurement. So this topic can be included either in computer inspection or in surface finish measurement, simple measurement. Because nowadays, surface finish measurement is all using computers. And the recent developments, last 10 years, 10 to 15 years, is the 3D stylus type instruments. This is not so old. And then interferometric profilers have become popular. And scanning microscope. So this is another method of getting surface finish measurement data. So another method which is available is use to measure surface finish. It's not really measurement. We can use standard roughness comparison specimen. So we have a plate here. So this is a plate which several surfaces are there. So, and what are their values are given here in this table. So you can compare this specimen with the part you have manufactured and determine what roughness it is. So this was one of the oldest methods. Okay, so it's very cheap, the surface finish measuring equipment. So the stylus type profilometer nowadays may be costing around 1 lakh or so. This may be costing around 5,000 rupees. You can get this surface roughness comparison standards. So light section microscope looks like this. So a source of light is sent through this narrow slit and the surface is illuminated. And we can observe this profile of the surface through a microscope. And we can measure R. In the older days, we were not able to measure the individual heights. So resolution was not that good to get all the points. So we used to measure only this maximum to minimum distance. So this is a light section microscope. I think nowadays it is, I tried to get a picture of this and I found a lot of old instruments are there for sale, but nobody uses this. In 1940, Talysurf, this is a valve-based instrument. So let's see. So we have a whole box of valves inside this cabinet. Plus a lot of things here also. So the valve technology was very space required. So Here you can see there is a stylus which is made to move over the surface, and the deviations of movement are captured using electronics, amplified, then computed. So that is Talysurf 1 in 1940, such a huge machine. Talysurf 10, I think by the 70s, with the transistor development, so Talysurf 10 became so small. So it became a tabletop instrument. So optical profiler. So nowadays we have instruments which give a 3D view of the surface. Not only view, picture, you can get the integer measurements at each point. So this is actually a false image. What we are doing is we are actually measuring the height of points on the surface from a reference surface using interferometry and generating a false image. So this is an optical profiler. Scanning probe microscope is another technique. Scanning probe microscope, atomic force microscope. So there is a tip which is very small, and it is made to scan over the surface, and the force of attraction between the surface and the tip is measured, and that is used to determine the profile of the surface. So the difficulty with this is a single tip, so you have to move it over the entire surface, so it takes a lot of time. So that is how the three-dimensional surface, the interferometric methods were developed, which you get a picture of the entire surface in a few minutes. Okay, so that is